Today we're going to look at the calibration of thermometers. In front of me I have four thermometers of three different types. So the first one is a standard digital thermometer. These are reasonably accurate and are not designed to be recalibrated, but you can get more expensive ones that allow themselves to be calibrated the same way the balances we looked at earlier do, in the fact that you can put them in a known temperature and tell it what that temperature is, and it will then realign its scale to that. And the other we've got a standard alcohol or liquid in glass thermometer. Okay, these are the ones you're most likely to be using in the lab and most likely will come across most often. And then the final type we've got is a mercury in glass thermometer. Okay, now these are not used as much now due to the toxicity of mercury and the issues we have with regard to cleanup and disposal. When we're calibrating a thermometer, we need to look at its range. So in this case, this one's a -10 to 110. Whereas with the mercury one we've got, it's a 50 to 100, and these digital ones do from -10 to 110 as well. So when we look at calibration, we need to make sure that we cover as much of the range as possible. So if we were only to do the temperatures, say between 50 and 60, it will give us a very narrow point of calibration. So we need to make sure that we do as many points as reasonable, which is normally anywhere more than 5, and that they need to be as far apart as possible. So we're going to use ice water and boiling water, and then what you'll be able to do is mix the two to get temperatures in between. So we'll be looking at something like 0, 10, 20, 30, 40, 50, up to 100, or near enough 100, because the freshly boiled water would be just below 100. And with this mercury in glass one, obviously we'd be looking at doing the temperatures between 50 and 100, so you might do 50, 60, 70, 80, or you might do 55, 60, 65. Now fortunately for us, the thermometers are designed in such a way that they are linear. So that means that the distance between 0 and 1 degree on the scale that you're going to create is the same as the distance between 99 and 100. So every degree is the same distance. It might be a millimetre, it might be 2 millimetres, who knows? But it's always the same all the way along the thermometer. So we've got a blank mercury in glass thermometer here, so there's no scale on it. And we're going to create a scale. So what I have here is I have some ice water, and I've just chucked some salt in it. Okay, just to try and get the temperature down a bit more, because obviously the greater the range of temperatures we can do, the greater the accuracy of our calibration. So we've got this down to about 2 degrees. Now what we would need to do is, we're using this as our standard. So this digital thermometer is what we're going to be taking the official reading as. We're going to take this as being accurate, and we're going to make this one match the accuracy of this one. Now what we're going to do is we're going to put our mercury in glass thermometer without a scale on into it, and we're going to allow it into the ice water. We're going to allow it to acclimatise. Now mercury in glass and liquid in glass thermometers are not instantaneous in their response. So what you've got to do is wait for the temperature to stabilise, and it's very important you do this, and the same goes for whenever you're doing a practical. So we would note, okay, that it's stabilised, and when we know it's stabilised, without taking the bulb out of the solution, we're going to put a mark, okay, and we're going to check that, okay, because obviously you want it to be done so that you're looking straight at it. If you're looking at it from an angle, it's the same as using a burette. If you're looking at it from an angle, you will not get a true reading. So we're going to record that the first mark was at 2 degrees. And then we would carry on doing this as our temperature increases right up until we've got our freshly boiled water. Again, we're going to put our thermometers in and we're going to allow them to acclimatise. Now this one's saying it's about 80 degrees because it boiled a couple of minutes ago. 82.9. Okay, so this thermometer stabilised and this one stopped going up. So we're going to put a mark and we're going to mark that down as being at 82.9. So what you can do is then you could measure the distance between those and then do a distance temperature graph to allow you to work out all the ones in between, or you could literally do 10 degree increments all the way up. So you'd have 1, you've got 0, you'd have a 10, 20, 30, 40, 50 and so on. That would only give you an accuracy of plus or minus 10. So the graph option is much better because you could plot the graph, you could measure the distance it's travelled from the start line and then read off the graph, and you should actually get a nice clear temperature. Thank you.